friends, my name is Akshay. So let's start our daily practice problem on Geeks4Geeks. So the problem is, name of the problem is replace O's with X's. Okay, so let's read the problem statement. Given a matrix mat. Okay, so we have a given matrix which name is mat of size n cross m, where every element is either O or X. Okay, in matrix the elements either X or O. Okay, replace all O with X that are surrounded by X. Okay, so it tells us we have to replace O with X if O is surrounded by X. What is the meaning of surrounded? Here I think it is clarified. So let's read it. O or set of O is considered to be surrounded by X. Okay, here is a written. O is considered, or set of O is considered to be surrounded by X if there are X at location just below, just above, just left and just right of it. Okay, so we have to check for set of O, the X is just below, just before, just left and just right. So we have to change 0 to X. Okay, so here we can look the question. N is 5 and M is 4. So in this case, this set of zeros, you can see here all left is X, all below is X. Okay, here this below X and the right side of all set of X. Okay, so it is changed by X. So in the output it is changed. Okay, it 0, its below is X, its above is X, its left is X, but right and below we cannot say, so it is as it is. The condition is it is must be below, left, right and above are X, then we have to change it O's, otherwise make keep it is. Okay, so here 0 is keep as it is, or this 0, the group of this 0, in for this here it is no any X above this group. Okay, so we have to keep it as it is, so here we keep it. Okay, so how can we solve this? Okay, so we can use this approach. Can you find this pattern if this is I barabar 0 and this is nth row, this is n minus 1th row and this is 0th row. Okay, and this is 0th column and this is m minus 1th column. Okay, so whenever O is occurs here, okay, if O is present here, so we can say that O is present here in this, the corner edges. So we can say that all O or all set of O which have O which in the this corner edge, so this group or O we cannot change, because for this O we have not one. If you look here, so this O have not any right, this O have not any left, this O have not any below X and this O have not any above X. Okay, so for this corner edges O have not any X for below, left or whatever, but it have not one X. So we can say that if O is here, so we cannot replace. Okay, so we can use one approach which is DFS. We check for this O and we use DFS for all surrounding elements. Okay, makes sense? What can I do? Okay, so for this we have to call our DFS for this only corner edges. Exist is 0, it is as it is. Okay, so for we take look for I barabar 0 to I less than n I plus plus. Okay, and for j start with 0, j less than m, j plus plus. Okay, and then call DFS. In DFS we have to give position I and j and our matrix and size of the matrix. Okay, so here we write our DFS, void DFS. We take I, j, this matrix, and here the size of the dimensions of the matrix. Okay, so we have to check, because we have to call DFS. So this 0 surrounding, we can go below, we can go left side, we can go above or below, or we can go left or right. Okay, so if we call here and we call recursively for this, we call recursively for this, and we call recursively for this, and we call recursively for this. But for doing this we have to check, if I is less than 0 it will not work, if j is less than 0 it will not work, if I is more than n minus 1 it will not work, and j is more than minus 1 it will not work. So here I write this condition, if I is less than 0, or j is less than 0, or I is more than n minus 1, or j is more than m minus 1. Okay, we have to check this. And if matrix of ij position is x, so we have don't change for this. So here we also check, if this is not x, so it means is 0. So if it is 0, mat ij not 0 but O, then it simply return the function. Okay, if it is not x, so it means is it 0. Okay, because here we have given two only, x or O. Okay, so you want it is x, so it will return. So we check for 0. Okay, if MIT is 0, okay, so this XOR give us false and it will not run. But if mat ij give us x, so this is x and this is O, so our this operation XOR give us true, and then it will return. Okay, so here MAT is x, at that time XOR give us true, and it will return the function. Okay, and not do any statement. So if the all conditions are false, it means we reach here this O, and we want to this O is keep as it is. So here we change the value of O for temporary, we have changed it as a n. Okay, and then call again DFS. We have to call it 4 times. First for I plus 1, if we reach here, okay, so we call for this, or for this. If we reach here, so we call for this, okay. So it means we visited here, and after we call function recursively again for the all adjacent element of this particular node when we current. So here we call I plus 1, we call I minus 1, we call j plus 1, and we call j minus 1. Okay, so here we currently here. So assume we are currently here. So this is visited, and then when DFS call for I plus 1 means this. So DFS called for this. Okay, because if this is 0, so we change this 0. In this test case you can look here why we write here I plus 1. If this is 0, so we want to keep it is same. So here we change value n, and then we have to change this O's to n, because we want this O will be same after the doing all operations. O will not change. So we call for this again, and then we call for this again, and we have to call for this. So here we write I same. In this case I is same, but j is j plus 1. Or assume if any O are present here, so we have call I same but j minus 1. Okay, and we start for here 0, and 1 0 is here present, so we have to call 0 for this and for this. Okay, so for right here j minus 1, I minus 1, I plus 1 or j plus 1 for calling the DFS. This is very simple to understand. Okay, and after doing this, here we forget one condition in if, because we want only corners, calling for only corners this DFS, not for another element. So here we write if I equal to 0, okay, or j equal to 0, okay, or I equal to n minus 1, or j equal to m minus 1. Okay, this statement. Okay, but we use this XOR for comparison, so we have right here and not or. Because why we write here and? We want to I equal to 0 or j equal to 0, or I equal to n minus 1 or j equal to n minus 1. Okay, we write understanding here I equal to 0 or j equal to 0, or I equal to n minus 1 or j equal to n minus 1. Apply De Morgan rule to it. So it means here we write this, and here we write and. Okay, and this equal to will change for does not equal to. Okay, we use De Morgan's rule, or instead of this we can write XOR. If you don't know, so you can use does not equal to instead of XOR. It is valid. Okay, you can write this if statement. So here I write only this. Okay, so this is statement for corner edges, and we call all elements for corner. And after doing this, which is question mark, we will again make 0, and rest of all 0 which is not questioned or not known, it will be x. Int I start with 0, I less than n, I plus plus, for int j start with 0, j less than n, j plus plus. Okay, and if we have to check this, our matrix of I j is equal to n. Okay, so we can write here does not equal to, here not, or instead of this we can write XOR. Okay, so it means we have to change this value as O. Okay, why? Because we have changed this O to N, which 0 we want to keep as it is after the changing this, after doing this process. So that 0 we have to give N. Okay, rename it N, its O's, and here we again change N to O. Okay, and rest of this N which O's are present in our array, you can look in this example, this O will be not N because we did not reach here all the corner elements. Okay, but in this 0 we reach here, so we change it value N, so it value is N, and for we changing N to 0 again. Okay, and else if ij is equal to, if it is equal to 0, so we have to change this to in X. Okay, so here our code is complete. It is a very easy course. This is very easy question. Okay, so here our question is completed. Just compile this. Okay, so what is our output? Yes, our output is exactly like to expected output. Okay, so let's submit this code. So yes, our submitted is expected. So here you can look, the code is very simple. We use simply DFS for this. First of all, we called all DFS for all corners. Okay, and here we called it, and then if it is 0 in the corner, so we change it 0 to N for doing this, and we call again DFS for its near, exactly near the elements. Okay, so in this case we call 0 for this. Okay, so we want to reduce some time complexity in this code, so here we can write, no, we can write also 0 for it will not call the function, so we can optimize this, but it will not make large difference. It is a really little bit difference. Here it is 0, so we change 0 to N, and then we call for this X, this and this, so it is X, so it both are written, but this 0 it will work, and this 0 change to N, and this calling for this, and it will change N, and this call to this 0, okay, and it will change to X, it will change to N. Okay, and after doing this, whatever N are present, we won't keep it is O's, so we change here which it is N, so we change it to O, and if any O are present, rest of O's which is not N, so in this case these are O is as it is, it will not change the value to in the N, so if it is O, so we have to change it to X and then return it. So code is completed, and thanks for watching my video, and so please like, subscribe my channel. Okay.